In section 5.6, we'll see how we can solve undetermined systems. So if I were to tell you to evaluate this limit here, what we will end up finding is that x squared, if we were to replace x squared by minus infinity, we'll end up with infinity, and then exponential of minus infinity, or exponential of minus infinity, which is exponential of minus infinity, will also give us infinity. So we'll end up with an undetermined value, which is infinity over infinity, which we don't know how to solve. This is where this rule comes in handy, the L'Hopital's rule. What the L'Hopital's rule says is that if we have two functions f and g, which are differentiable on a and b, containing a number c, except possibly at c, which means that the two functions are differentiable on the whole interval ab, but not at c. Then if we assume that g prime of x is different than 0 for all x in ab, except again at c because c is not differentiable, if the limit of f of x over g of x as x approaches c produces the undetermined form of 0 over 0, then we can find or we can say that the limit as x approaches c of f of x over g of x is just the limit of the derivative of f over the derivative of g. And that's provided that the limit on the right exists or is infinity, which means that if we were to evaluate the limit at c plus, we should find a limit, or at least the limit should be infinity. This result also applies when the limit of f of x over g of x gives infinity over infinity instead of 0 over 0, or minus infinity over infinity or any case here. So this can work in case we find 0 over 0 or infinity over infinity, or any of these choose values if we were to multiply infinity minus minus or anything like that. So now let's try to apply that to the first example that we were trying to solve and that we couldn't solve before. So we have the limit as x approaches in minus infinity of x squared over exponential of minus x. If we were to apply the L'Hopital's rule, differentiate x squared and exponential of minus x, and we'll end up with 2x here over exponential of minus x is just minus exponential of minus x. Then we'll end up with 2x or minus 2x over exponential of minus x. However, this is all limit here, and this is also limit. If we were to evaluate again this here, we'll end up again finding that we'll have plus infinity here over 0, or infinity rather. So again we ended up with infinity plus infinity over infinity. So again, infinity over infinity is one of the values, or the cases where we can use L'Hopital's rule, just like we did with 0 over 0 and infinity over infinity. So again, we can again apply the same rule, and we'll end up with we had 2x over exponential of minus x, and this again, if we were to differentiate, we'll end up with minus 2 here over minus exponential of minus x, and this just gives 2 over exponential of x, and the limit again at minus infinity will just be 2 over or minus here, so 2 over minus infinity or plus infinity, so this gives 0, and then we'll end up with just 0. So this is how we can apply this rule, or the L'Hopital's rule.